Welcome to Endless Learning Training Series, the membrane-based desalination technology.
In this presentation, we will be discussing what is CV, why is valve CV important, how to select valve size based on the desired CV value, is higher CV better for valve, factors affecting the CV value of a control valve, the importance of CV in control valve sizing and selection, as well as its applications. CV of control valves. What is CV? CV stands for valve flow coefficient. Valve flow coefficient, CV, is the flow capability of a control valve at fully open conditions relative to the pressure drop across the valve. It is defined as the volume of water, GPM in the US, at 60 degrees Fahrenheit that will flow through a fully open valve with a pressure differential of 1 psi across the valve. It is a measure of a valve's ability to control the flow rate of a fluid through it. It is a standardized measure used to compare different control valves and their flow capacities. CV plays a crucial role in control valve sizing and selection as it determines the maximum flow rate that can be achieved through the valve. It is useful to know how to calculate CV because it is the standardized valve sizing and selection method for control valves used throughout process industry. Factors affecting the CV value of a control valve. Valve size and shape. The size and shape of the valve orifice can affect the CV value as it determines the maximum flow rate that can pass through the valve. The larger orifice size generally results in a higher CV value, allowing for a higher flow rate, while a smaller orifice size results in a lower CV value and lower flow rate. Valve design. The valve's design can affect the CV value, particularly the valve's flow characteristic and valve trim. The flow characteristic refers to how the valve's flow rate changes in relation to the valve's opening position. The valve trim, which includes the valve plug, seat, and other components, can also impact the CV value and flow rate. Fluid properties. The properties of the fluid being controlled, such as viscosity, density, and specific gravity, can impact the CV value. Fluids with higher viscosity and density typically result in lower CV values and flow rates due to increased resistance to flow. Differential pressure. The pressure drop across the valve, or differential pressure, can impact the CV value. A higher differential pressure results in a higher CV value and flow rate, while a lower differential pressure results in a lower CV value and flow rate. Understanding these factors and how they impact CV is critical in selecting the appropriate control valve for a given application. Process temperature. The viscosity of fluids generally decreases with an increase in temperature, which can increase the CV value of a valve as the fluid can flow more easily through the valve. However, if the temperature is too high, it can cause the fluid to vaporize or change state, leading to issues such as flashing or cavitation, which can significantly impact the valve's performance. Importance of CV in control valve sizing and selection. CV is an important parameter in control valve sizing, as it represents the valve's ability to control flow rate for a specific fluid under given conditions. The CV value of a control valve is typically determined by the manufacturer based on standardized testing procedures and is provided in product documentation. For properly size a control valve for a given application, the required CV value must be determined based on the system's flow rate and pressure drop requirements. Correctly sizing a control valve with the appropriate CV is essential for ensuring efficient system performance and optimal flow control. A control valve with too low or too high CV can result in a range of problems, such as inefficient system operation, excessive energy consumption, or potential damage to the valve and system components. Understanding the CV requirements of a system is critical in selecting the right control valve for the application. Guidelines for selecting an appropriate valve size based on the desired CV value and other system parameters, ANSI/ISAS 75.01. This standard provides guidelines for selecting the correct size of a control valve based on the flow rate, pressure drop, and fluid properties of the system. The method involves using the valve CV value to determine the valve size and trim design, taking into account factors such as the valve's inherent flow characteristic, system design, and other relevant parameters. IEC 60534-2-1. This standard provides a similar approach to valve sizing as the ANSI/ISA method, but with more emphasis on the valve's control performance and less on its physical dimensions. The method involves selecting a valve size based on the required flow rate, pressure drop, and other system parameters, and then selecting the appropriate trim design to achieve the desired control performance. Both of these sizing methods are widely used in the industry. How to calculate CV for a control valve, flow rate through the valve. Q equals A times V, CV equals Q slash square root, delta P slash SG, where SG equals specific gravity, SG, is the ratio of the density of a substance to the density of a reference substance, typically water at a standard temperature and pressure. It is a dimensionless quantity that indicates how dense a substance is relative to water. Value can be used to select a control valve that is appropriately sized. Calculate the CV, for example, using the formula CV equals Q slash square root, delta P slash SG, substitute the values of Q, delta P, and SG to calculate the CV value. Here is an example calculation using the following values. Flow rate, Q, equals 50 GPM, differential pressure, delta P, equals 15 psi, specific gravity, SG, equals 0.9, CV equals Q slash square root, delta P slash SG, CV equals 50 slash square root, 15 slash 0.9, CV equals 12.24. How to calculate CV for a control valve, step by step. Determine the flow rate, determine the required flow rate for the application in units of gallons per minute, GPM, measure the differential pressure, measure the pressure drop across the valve, also known as the differential pressure, in units of pounds per square inch, PSI. Determine the specific gravity. Determine the specific gravity, SG, of the fluid being controlled. Selecting a control valve. When selecting a control valve, it is important to consider the required flow rate, pressure drop, and fluid properties of the system to ensure that the valve's CV is appropriate for the application. A control valve with a CV that is too small may not be able to provide the required flow rate, A control valve with a CV that is too large can result in excessive pressure drop and unnecessary energy consumption. The CV value should be used as a guide in the valve selection, but before trying to match a valve with the calculated CV value, some other considerations are: decide what type of valve, globe, ball valve, etc., will be used for a given process characteristic. Avoid using the lower 10% and upper 20% of the valve stroke. The valve is much easier to control in the 10 to 80% stroke range. Select a valve for which the CV falls between 20% and 80% open stem travel is recommended. Overall, selecting a control valve with the appropriate CV is critical to ensuring optimal system performance and minimizing the risk of cavitation, excessive noise, and other problems associated with poor valve selection.
Thank you for watching this video.